In this problem, we're told that a fish at rest propels himself forward by creating two vortices with his tail. The fish moves at 5 centimeters per second to the left, and each of the two vortices move at 10 centimeters per second at an angle of 15 degrees above the horizontal. We're asked to determine what is the mass of each vortice. The main idea that we'll employ to find this mass is conservation of momentum, meaning that we'll find the momentum of the fish when it's at rest and equate that of the momentum of the fish and vortice system and use that equation to solve for the mass of the vortex. The fish is initially at rest, so that means its initial momentum is going to be equal to 0 because it's not moving. With this condition that the final momentum of the fish and vortex system has to be equal to 0, we will be able to write an equation that will allow us to solve for the mass of the vortex. In this step, we're going to find the momentum of the fish and vortex system. Because momentum is a vector, we need to find both the x component and the y component of momentum. Let's look at the x component first. The fish is moving 5 centimeters to the left, and each of these vortices will have its own x component. So if we look at our equation for the x component of momentum, we have the momentum of the fish in the x direction, plus the momentum of the first vortex in the x direction, plus the momentum of the second vortex in the x direction. We can write each of these momentums in terms of the mass and the velocities, which leads us to negative mass of the fish times the velocity of the fish, because the fish is moving in the negative x direction, plus the mass of the vortex times the velocity of the vortex in the x direction for this vortice here, and the mass of the vortex and the velocity of the vortex in the x direction for this vortex. And we can simplify by combining these two terms to write that the momentum in the x direction is the negative mass times the fish times the velocity of the fish, plus 2 times the mass of the vortex times the velocity of the vortex. Now let's look at the y component. The fish is moving in a purely horizontal direction, so it has no vertical momentum. The only momentum in the y direction comes from each of these two vortices. But we're told that each vortex is moving at the exact same speed, at the exact same angle, and will have the exact same mass. So what will happen is the y component of momentum for this vortex will cancel the y component of the momentum for this vortex, which we see here in this equation, leading to the condition that the momentum of this system in the y direction is equal to 0. At this point, we can now solve for the mass of the vortex. Using conservation of momentum, we set the momentum in the x direction of the fish and vortex system equal to 0. Again, that's because the fish is initially at rest, and so its initial momentum is equal to 0. And substitute in for this pf of x the expression that we just derived. We can solve for the mass of the vortex by moving this term to the left-hand side and dividing by 2 times the velocity of the vortex in the x direction. We then rewrite this term here as the velocity of the vortex times cosine theta because we only want the x component. We substitute in the values given in the problem statement and evaluate to find that the mass of the vortex is 3.88 grams.